will introduce about the numerical integration phase. Numerical integration is the approximate computation of an integral using numerical techniques. Let's say integration of 0 to 3, where 1 plus a squared to the power 3 over 2 dx is the numerical integration. It will not give you the exact value, but can give you the approximate value, because integration of 1 plus a squared to the power 3 over 2 cannot be found. Then the next question is, why do we need numerical integration? We need a numerical integration sometimes quicker than tracking down a complicated integral. Sometimes it's good for checking that we understand a definite integral by using numerical tests. Third one is many functions cannot be integrated analytically. This one may want to integrate an experimentally measured function. Okay, I just start to the trapezium rule. Okay. Actually, the area of the trapezium rule is half center of the parallel side multiplied by distance between them. And to summarize the trapezium rule, apply you just need to find the width of each strap, and the width of each strap is equal to the upper limit negative over lower limit by number of strips. Then use the formula of the trapezium area to find the area of the trapezium. And actually, area of the trapezium is half center of the parallel side into distance between them. So for the first area, 1 over 2 into the circle parallel sides are y0 and y1. So at the y0 and y1 into multiplying the width of the strip. Width of the strip is h. Then the second area is here. So the second area, for second area, half into parallel sides are y1 and y2. Then at the y1 and y2 and into the height of the width, height of the strip, then h. Then all the way to the end strip. Then next step is take the h over 2 as a command, then write down the length y0 plus 2y plus 2y2. Then the next step is h over 2 into, first you need to write down the y0 plus yn. Then another is take the 2 as a command and write down the length. Okay, here is the trapezium rule. Another one got example 1. Example 1 is have to evaluate integration 0 to 1, where square root of 1 minus h2 dx using the trapezium rule with 4 strips. Let's say f of x equal to square.
Continue with the.
Yeah, here got example 1. Example 1 is to find the integration of 0 to 1 when square root of 1 negative h2 dx using the trapezium rule with 4 strips. Let f of x equal to square root of 1 negative h2. Here is strip number. Number of strips is 4. Then find the length of the each strip first. H equal to upper limit 1 negative lower limit 0 over number of strips. Number of strips is 4. Then become 1 over 4 equals 0.25. Then you have to make the table x and y. the first value of x should be the lower limit. So the lower limit here is 0. Then the second value should be the less value plus 0.25, the height of the strip. So this one becomes 0.25. Another one also called 0.5, all the way to the 1. 1 is the upper limit. Then you have to find the y. Y equal to square root of 1 negative x cubed. Then for the value of x, y is 1. For the value of x equals to 0.25, y equals 0.9922. For the value of x 0.5, y equals 0.9354. All the way to the 1, for the value of 1, y became 0. Then use the trapezium rule. Integration of 0 to 1 square root of 1 negative x cubed dx approximately equal to the h over 2 the whole bracket y0 plus y4 plus 2 into y1 plus y2 plus y3. Then put the value of h is 0.2 over by 2 into y0 is 1 plus y4 is 0 plus 2 into, then put the value of y1, y2, and y3, then we can get the answer. That's all for the example 1.